So if you're new to these videos, hello, my name's Kyle Houchins. I'm a tech and a trainer for McNeil, and I do industrial design, product design. I briefly worked as a car designer. I was trained as a car designer. I spent most of my time in the toy industry and product design and entertainment design and all that kind of stuff, and have been a Rhino user for 1 billion years since version beta, and worked in Alias and have done 3D modeling. I started 3D modeling in about 1992, and so I'm officially an old person in this business now. But these videos are a little different than what you may have been used to as far as software demos. And the way that I typically do these, and I was joking about it earlier, is I usually do a sketch the night before or the morning of or 15 minutes before. And then I put the sketch away and I don't look at it again. And then I bring it out and I build it live in front of everybody without any practicing or any, we don't do any Julia Child stuff where stuff is built on another layer and we poof it into existence. We build it live. If it goes wrong, we talk about why it went wrong. If it goes right, then we high-five each other and have a good time. These are intended to be interactive, so if you have a question, please hit the chat. They are recorded, so I'd prefer if you didn't use your mic and camera because it burns up bandwidth. But I do keep an eye on the chat. I am absolutely more than happy to pause, do a little off-ramp discussion, and talk about something that may or may not necessarily have intentionally been part of the video. We tend to find the way along the way and do some talking about, how to build this stuff and how to think about this stuff and all that kind of thing. So with that out of the way, let's get started. We're going to build this ball peen hammer today, which I'm a tool nerd. I like to restore old cars and have a little workshop here and do all that kind of stuff. And this ball peen hammer is one that I have in my collection, and I really like it for some reason. There's just some hammers that feel good in your hand and some don't. And I'll use one for a while, and if I don't like it, I'll actually usually just give it away or donate it to a tool library or something like that. But this one is a keeper, and I've had it in my collection for quite some time. So the interesting thing about it is the head on this thing has actually a lot going on, and I have it sitting here on my desk. You can't see it, but as I turn this thing around, it's actually got a bunch of different shapes that are kind of pulled together in order to make this thing happen. And I thought that it was actually kind of an interesting shape to talk about. So the way that we'll do this, let's go into a little chalk talk here. And if we take a peek at this and think about kind of what we're going to do and how we're going to do this. The main shape here is essentially just a NURB surface, right? We're going to create some profile curves. We'll talk about proxy objects and how to get things with continuity over the center line. But basically, we're going to make a couple of profile curves, and we're going to get 99% of this just with a couple of curves and a couple of blend surfaces. This up here, that's a primitive object. This back here, that's a revolved object. This is where the fun begins. And there's a couple of shapes in here. There's one shape that kind of goes like this. And it actually has, if we look at this in perspective, it kind of goes like this. It's almost kind of like a bladed shape, and it has a section kind of like that. And then there's a secondary section in here. There's a secondary shape in here, which is kind of this guy. And that kind of lives on top of this thing, slightly offset like this, and has a section kind of like that, right? And these two things have to kind of work together and blend together. And then there's all sorts of little blendy fun that we're going to have kind of in here. And we'll see how that works and see how that works out. And we'll burn that bridge when we get to it. So that's kind of the strategy. This kind of stuff is easy. That's just projected curves and a little push-pull. These are all just projected curves. This is all just projected curves. All that stuff is kind of easy. So we'll we'll kind of blow through that quickly, but that's in a nutshell, very simply how we're just going to come over here and do this, that, and the other thing. And then, and then done, right? Welcome to my videos. All right. So let's go ahead and get started with anytime I do a video like this, I always start with an image of some sort. And in this case, this is no different. And the way that we get that in is we just run the picture command. We find our picture and we just drag it into the scene, and we can do whatever we want with that. And since I've already got one here and I've already got it on a layer, I'm going to skip that step. But if I pick this and go, should we have the program open and be doing this? No, you're not going to be able to keep up with me. That's not a brag. That's just a fact. We're going to move really fast. So what I would prefer is if you take some notes and then just watch the video afterwards. That way you can watch it at your speed. You can rewind, pause, do all that kind of stuff. So yeah, just watch and feel free to ask questions. If I do something that you're not, you don't understand what's going on, just hit the chat and let me know, and we'll go from there. In the materials tab here, if I pick this, you'll see that we have a material assigned to this. This is the picture, and you can see that it's a picture type of image right here. And we're just going to crank the transparency up a little bit, and that's gonna fade that out so that we can work over it. And then the other thing I want you to notice is I actually have this stuck back in space a little bit. And the reason for that is if I were to model something at the center line, which is where we're going to be, and you go in shaded mode, if the image is in here, you can't see it. So I typically stick it back in space so that I can see it as I'm rotating around, but in front view, it's still oriented and all that kind of stuff. All right, that makes sense. So I'm going to lock this so now it's not selectable, and we'll just jump in and get rolling. So the first thing, the easiest get here is let's just draw some curves. And I'm going to come in here and just approximate where all that stuff is going to go. Now, I could have machine gunned points down here and gotten this really close. But I don't want to do that. I want to follow rule of three. And if you don't know what rule of three is, there's a video there, and I always talk about it. But rule of three essentially is it only takes 3 points to make a transition, right? If we have 2 points, we can't make a transition because there's no points in the middle. If we insert a control point into the middle here, now we have 3 points. Guess what? Now we can go up or down. And in this case, that's a polyline. But if we look at this now, in this case, now I can make a transition. I can go up or down. And if I want to make an S shape, then I need a 1, 2, 3, 4. Now, the interesting thing about this curve, even though it only has 4 points, it still follows rule of three, because 1, 2, 3, these points make up this transition, and 1, 2, 3, these points make up this transition. Now, the nice thing about this is because I'm sharing points between these two, these transitions blend nicely into each other. If I needed these transitions to happen independently from each other, I would need to actually have more control points. I would need to have 1, 2, 3 for this one, and I would need to have 1, 2, 3 for that one. Now I can grab these points. This leads into a much longer discussion about continuity, but I want to give you kind of the TLDR on this. So now I've got 1, 2, 3 makes up this transition, and then I've got 1, 2, 3 that makes up this transition, and those can function independently from each other more or less. Now, there is a second set of 1, 2, 3 right here, which now shares between these, which is the blend between these two, and this 1, 2, 3 now controls either the blend between the 1, 2, 3 on the left and the 1, 2, 3 on the right, or the transition of the 1, 2, 3 between the two of those, depending on how they share. So the concept here is we don't want to do curves like this. We don't want to, I see beginners do this all the time, you know, and you end up with a surface that looks like that. And then you go down the road and you say, why are my fillets weird, and why is it hard to model, and why is it hard to edit, and why is everything hard, and everything's hard? It doesn't have to be. If you look at this shape, right, it's got a high point, a low point, and a high point. 1, 2, 3. Boom, right there. Then it transitions from this high point back to a low point, back to a high point, which means I have to have a point at the high point, I have to have a point at the low point, and I have to have a point at the high point again. 1, 2, 3. 1, 2, 3. 1, 2, 3. Once you understand this, this is like the very basic building block of NURBS modeling and sub-D as well, because sub-D follows the same rule. And so if we're going to make a corner, we have an anchor point. We have 1, 2, 3. Anchor point. This is our transition right here. If we want it tighter, we move these closer. If we want this looser, we move these farther apart. This is the exact same rule with sub-D. If we look at sub-D, and I don't think we're gonna do any sub-D on this end unless things get really wild. But sub-D follows the exact same rule. If we turn the points on for sub-D, look what we've got. Anchor, anchor, 1, 2, 3. If I grab these edges and I move them closer, what happens to that corner? If I grab these edges and move that closer, I move it farther apart. Okay, so that's all you need in order to make a shape. And so then now you start looking at things differently. And you start saying, okay, well, where are the transitions? Where are the inflections happening? And so in this case, we have a point here. We have a point that's going to land somewhere in there. We have a point that's going to land somewhere up there. We have another one that's going to kind of pull in like that. And then we've got one that's going to land there. And that gives us everything we need. Now, we might fuss this a little bit. Just with our nudge keys, we may pull this out just a hair and do some adjusting, but that is the bones of our curve. We don't need any more than that. The only time we would need more than this is if there is a sub-transition somewhere in this curve that we missed. And by a sub-transition, I mean if we had a out, in, out, but we missed it and there actually is a second transition like somewhere down in here, then we would just need to simply add another control point and get this secondary transition which lives down here, right? So if this curve changed shape on us or changed speed on us or something like that, you know, there's a million ways to refer to that. But if the shape on that changed so that there was a sub transition somewhere in there, then you'd need an extra point in order to get the 1, 2, 3 to make that. Okay. Now, because we're going to blend over this, I'm going to just take this curve and I'm going to mirror it. And the reason I'm going to do that is because now all my points match, and this thing is going to be a lot easier to get a blend that behaves itself the way that I want it to behave itself. I don't want to have crazy isoparams crossing each other. I don't want to have, you know, a whole mess of stuff to deal with as far as that's concerned. So I'm just going to do something like this. Now for reference, I'm going to just draw a straight line across the bottom of this. I'm going to change degree from 1 to 3, and that's going to give me a degree 3 curve with 4 points, which is super easy to edit. And I can just change that to do what I want it to do and get my shape there like that. So that's the bones of how we're going to build this handle. Now, we're just going to grab gumball. We're going to extrude those back, and you'll see that we get really nice, clean, in this case, single span surfaces, which is really nice. So now I go and I grab my blend tool, which lives in here, I keep using my pop-up. I'm going to show you where it is. It lives in here. And we're going to blend from here to here. And you can see that we get a really gorgeous transitional surface. We know it's going to be, we don't even need it to be curvature. We're just going to go that, and then we're going to say this is going to be the same height. And then we're going to lock these handles, and we're going to adjust our shape here. Check that out. Anytime you need to build a shape like this, a grip for anything, a grip for a drill, a grip for a ski pole, you know, any type of handle for anything. This is one of my favorite go-to techniques for being able to do this. The thing that I like best about it is it's super easy to control. It's super easy to control your shape. You know it's going to be tangent across the center line, so you're not going to have any fins or butts at the center line. And the surfaces that you end up with, we can delete these now, are wonderful, right? That is a really nice shape. And if we change that to rendered mode and we throw a material on this so you can see what it looks like. You can see that we get really nice geometry there. Okay, so that's the heavy lifting for most of our handle. There is a secondary thing that's going down on here because of the way that this is shaped. We can actually probably get that shape a couple of different ways, and I was gonna see if we could cheat and pull the points, but I don't want to increase the density of that. So let's do a loft, and we're going to loft from here to here to here, and let's let that do that, and let's see if a couple of our options get us something a little nicer. Something like that, but I don't like this shape side to side, but I'm going to say okay because this is going to give me what I need to get there. And in this case, all I need to do is grab these points here and this point here and scale these together a little bit, and look what happens. See how that changes shape? And that gives me a really nice cap over the end of that thing. Now, the one that I have here, it actually, I think this is a product of a bad drawing instead of actually the shape of the bottom of this hammer, because the one that I'm looking at my desk is actually fairly flat. So I'm actually gonna cheat. I'm gonna scale this up just a little bit and flatten that out. I think I'm gonna let the model dictate reality instead of making the model follow the drawing. It's always important to, you know, reality check yourself and make sure that your stuff always makes sense. So that's closed up at the bottom now, and then we can add a fillet or a blend on that, but I don't want to get ahead of myself at this point. Now up here, we've got a little bit different shape. This thing has an oval shaped recess that, you know, part that sticks up. The hammerhead kind of sits down on this on a flat. Actually, it's kind of tapered. And so I think what I'm going to do is I'm just going to cap this. And then I'm going to do some gumball tricks, which I'm going to Control-Shift-Select this. And I'm going to just extrude up another little puck here. And then I'm going to Shift, Drag, Scale this thing to bring it in. So I'm going to just Shift, Drag, Scale to bring it in. And then I'm going to bring it down just a little bit. Got a grid snap on it. I don't want that. To give me a little thing like that. And then I'm just going to extrude this up again. So we get this little transition for free here, and I can blend and get that. Or I can delete this and use a blend surface to get a little blend surface. That's actually one of my favorite tricks, so let's do that. Let's just delete that. move this up a little farther. Can always change it later. And then let's run blend surf. Let's chain it. And that gives us blends on either side. Now in this case, this one is actually fairly sharp. So I'm going to take that one and sharpen it by moving that closer to 0. You can override this, by the way. The dialog box stops at 0.25, but you can actually override that and make it sharper. Now, it still has a little teeny fillet on there, a little teeny transition on there, but it's less than it was before. And let's take this one and push it down like that. That's a lot easier than using the blend surfaces and all that kind of stuff. Can we dimension the set? Since I say I want the handle to be 300 millimeters, for example. I'm glad you mentioned that. I actually did scale this to be somewhere in the 300 millimeter range. So yes, when you scale the drawing, typically what I'll do is I'll say, I'm going to take and make a 300 millimeter line, and then I'm going to scale the drawing somewhere in there to match that. I get flamed all the time for not measuring my drawing, so I actually measured this one. I've done entire demos where I'm like, and great, and then I find out the thing is like 17 feet tall or an inch and a half long. When you're just doing a demo and it's never going to get actually made, I don't worry a ton about that, but in this case, I actually did. So let's take a look at wireframe, and then let's go ahead and just finish up our details here and get our handle done. And then I'm procrastinating getting to the hammer because I know how to do this stuff, and I haven't quite figured out how to do the handle yet. So let's follow our 1, 2, 3 rules. In this case, we're probably going to do this. And that gives us our structure, and now we just need to adjust a little bit our shapes. Once you start following that 1, 2, 3 rule, all of your curve creation woes are going to start fading away, because the stuff is just going to make sense to you as far as what your shapes are doing and what you want them to do. And it's like you won't end up with these crazy inflections and stuff in your surface that you don't know where they came from, because you'll be able to see exactly where they came from. You know, if I had 6 points in here, the surface is going to go all over the place, right? You don't want that. So in this case, it's like I know where this corner is coming from. So if I need to adjust it and make it softer or sharper, I know which points make that shape up. In this case, I think I want this to come over a little bit more like that. And there's a couple of ways that we can do shapes like this, and I think let's give this a shot. So let's copy paste this, and let's turn the points on for this one and point edit our offset in. Now everybody's going to say, or you may be asking, like, why didn't I just use offset? Well, because offset can actually, let's use offset and I'll show you about that. If we go into offset and I were to offset this thing 2 millimeters, or actually let's do 1 millimeter like that, and I don't want to cap it, and let's do something like that. That probably works. And I look at this curve. Bleh. That's exactly the opposite of what I want, right? So let's run offset again, but let's use the loose option. What that does is you'll see it actually takes the points and it just moves them normal to the old curve. Now, this is less accurate than the typical offset, but it's a lot nicer from a curve point of view. So I actually like that personally. So let's project this through, and we can hide this. And now we've got the shape. Now, if the world is kind, we can use push-pull, and we can push-pull this in a little bit. Now, in version 9, I would have been able to get both sides of this. And so that worked out all right. But in version 9, I'll be able to select both sides of that and just push that in. But that actually worked out quite well. And we can put a little fillet on that if we want to later, but I'm not going to worry too much about it right this minute. All right, so let's look at the rest of our details in here. And we'll do, let's see, do we want rounded rectangles or do we want ellipses? What does this thing look like? Looks like ellipses. We'll go with that. I'm going to use a 2-point ellipse and just go like that and like that. And then I will, let's draw a curve. Like that. Vaguely resembling our other curve. And then we'll array this down the curve. So we'll do a transform, array, along curve. That's the object. That's the curve. We want, how many do we want? 1, 2, 3, 4, 5, 6, 7, 8, 9 of those. Something like that. And that's obviously more precise than our original drawing was. So I'm going to take it and I'm going to cheat this one just over a hair. Like that. Let's mirror this and see how close we get. It's just easier than drawing it again. Shapes aren't exactly right, but let's see what we can do. Just rotate this a little bit. I think I'm going to call that good enough for demo work. And then our rounded rectangle in the center. And I'm going to take this and I'm going to move it between these two items. Let's see, let's pick one. So we'll move it between these two. So if we say move, that's our object to move. And then we're going to do that. And the point to move from is going to be the center of this guy. So there. And then we're going to use the B switch. So we're going to hit B enter, which says we're going to move between here and here. And so I know that this is dead centered. And so now I just need to move it down a little bit. And in this case, there is a offset in here. So I'm going to copy paste. And I'm going to just shift scale this in a little bit. Or I could use offset with the loose. Let's do that. That worked all right. So let's do that. Offset. Could you mirror the ellipses? Could you mirror and the ellipses would be inverted directly? Yes, if my shapes were exactly, if the left side of the hammer and the right side of the hammer were identical, but they're not. So when I mirrored it, they were like, they didn't quite match up. So we're using the loose option, and we're just going to pump that in, and then we can just double check and make sure that our curves aren't crazy. So this, I'm going to take these all not these. And I'm going to project those on. And then we can use push-pull. Drop that in. Now, nice thing about push-pull, if I just pull this in and I don't click again and just hit enter, it's going to know it's going to go in, but it's going to remember the distance from the last one. So this one and this one now match. And then for these guys, these are actually through holes. And so I think what I'm going to do actually is I'm going to retool my thought here and get rid of these. Keep these. And instead of using push-pull for those, let's grab all of those. Those, not those. And let's just use gumball cut. I like this one. So what we can do is grab this, use the little slash here, and it should just rip right through there. If you didn't know what all those other little buttons on the gumball do, there's some cool stuff in there. So let's take a look at what we've got. So this is actually starting to look really good. And if we want to procrastinate further, we can call this, we can dig into this handle a little bit and do the blending. Where are we? 935. Okay. I think that gives me enough time to procrastinate. I saw a really funny quote about procrastination the other day. It said, "I'm not procrastinating. I'm just waiting for panic to focus my efforts." I thought, wow, I feel seen. All right, so let's blend this. And how did you do the holes? Yes, let's talk to that again. So let's undo that. So we've got an object, we've got curves. We want these curves to make holes in this object. We're going to grab this little slash on gumball. This is a cut. If you hover over it, there's a little cheat sheet that pops up. This is cut. Click and hold, drag it through the model, or hold down shift and it'll go both directions, and then let go, and it does a wire cut right through the part. Cool? All right, let's do some blending down here. Now, filleting is one of the things in Rhino that is much maligned, and it earns some of that, some of it doesn't, and I'm going to show you some tricks to get around it. Now, one of the first things you can see right here is this is going to fail because the fillets are red. So if I run this, that means there's something going on right in here that is going to make that fail. And if we preview it, you can see what happens. It chokes right around the center line. So let's not even worry about that. Let's do this. I'm going to extract that surface, and I'm going to draw a box, and I use a box just because I'm lazy. Keeps me from having to draw two lines. And let's just trim a hole here. And you can see maybe where our problem lies. Our problem lies right in this area right here. See how that's misbehaving? Let's figure out what's going on there. So let's undo that. And we might be able to get away with having our fillet behave if we fix what's going on here. So let's look at the points and figure out what's going on. Now, what's going on is you can see exactly what's going on here. See how the points are doing this right here? So this surface is a little bit kind of undefined for probably what it needs to be. And so maybe if we change degree on this from 3 to 4, we can get a little clearer picture of what's going on. And it might be as simple as if we take this row and we scale it flat like that. So we've got tangency there, and then we take this row, double click the control. I'm moving the gumball to where I want it to scale to, and then scaling that to 0, and that will smash that flat. Now I've got a tangency situation going on the end of that, and it gets rid of that little discontinuity that was happening there. Let's see if that makes any difference when we run a blend around here. It may not. Let's see. So it actually does a much nicer blend around there. But I think I want to take this one step further. I mean, we can run it and let's see what it did. It actually did an okay job. Maybe we call that done. I'm going to call that done. If you want to dig into this further and you wanted a more complicated blend, it's just a matter of modeling a gap. Can we get an explanation on Grasshopper? Not from me. You're gonna need somebody a lot smarter than me, like Jaffe or Brian James or Steve Fuchs. I'm not a Grasshopper guy. So if you wanted to dig into this deeper, you can look at the structure of this and say there is a surface there, there is an edge there, there is an edge there. If I wanted this fillet to do something differently than it's doing, all I would have to do is change the shape of these edges in a way that makes my shape do what I want it to do. Now, I've got two parts of the structure I had before. I just am missing the middle part. Well, the easiest way to put the middle part back in is just to grab blend surf. Let's do chain. Now we've got control of this, how the tangency goes together. I can even change the shape internally on that. I can go to curvature, not for product design. Some people get bent about that, but tangency for my money, tangency is kind of as far as product design is ever going to go. And so now we've got a different shape going on there. Okay. Now, could you have gotten that with blend? Maybe. If you'd add handles or something like that, that's fine. But I like being able to define that stuff myself. So let's go in and let's do some itty bitty teeny tiny little fillets in here. And we're going to set all, let's do like 0.25. Looks like that's still self-intersecting, so let's make it even smaller. That looks like that's getting close. That looks like that is completing without any drama. So let's call that good. And then we'll do the rest of these as well. I like to just test it on one to make sure that it's going to do what I want it to do. And then roll it out for the rest of the crew. Otherwise, you get to wait while it calculates all of them and then find out it failed, and then you change it. It has to calculate for all of them, and then you find out it failed, and it's annoying. So these little fillets are the things in product design that kind of make or break the model when you're doing renderings. And there is an edge softening tool that you can use if you don't want to model all of this stuff just in the render mesh. If you hit the F1 key and search the help for edge softening in Rhino, there's a whole thing on how to use that. And we still got a closed poly surface. It's a good idea to keep an eye on that to make sure that as you do this stuff, you're not interjecting some kind of wonk into your model. That's not super awesome right there, but I'm going to let it roll. There's a little peak right there that's not cool, but it's probably a product of the offset. If I was going to do, I'd probably print it, take a look and see what it looked like, but if it was going to be too disruptive, I would go in and fix that. That 0.08 fillet seems to kind of do what I want it to do, so we just want to crack those edges off. All right, and I think that gives us our completed handle. So let's make a new material. And we'll make that kind of a gray. And we'll do this part gray. And yeah, all the rest of the stuff looks right. Let's change the properties on this a little bit. Let's make this a little matter. And let's make that a little less clear. Actually, let's change this paint to a plastic. And then that way, the nice thing about the plastics is they even have a bump texture in here. So like if we wanted to put a texture on that. Let's see, didn't want it on that one, wanted it on this one. So now that's got a little bit of a texture to it. And fun fact, if you take this and change it from a plastic to a physically based, and you look in the bump channel, you can see that the default value for the speckle texture is 10%. If you take that and raise it, you get more specklies. But you have to switch it to a physically based in order to be able to get that setting. All right, let's save and call that good. This is my redemption song, so we're going to call it Hammer Doesn't Suck Yet. And let's dig into the head of this thing. So we've got two very easy to model shapes. The one, let's grab the easiest one, which is this, and we're just gonna make this like that, and direction constraint is none, so we're gonna pull it in that direction and go there. And let's do this and shade it so we can see what's going on. And then this guy, I'm gonna call this a half a sphere. So let's just do that. And it's actually slightly oblong. And there's a seam here that I want to not have be part of my model. So I'm going to actually rotate this 180. Because what I want to do is actually trim this just past the center line. And then what that does is that gives me a surface that is now seam free, and I don't have to worry about what to do with it. So the shapes on this, let's get into the shapes on this. So we have a shape that starts like this, 2, 3, comes over here, 2, 3, like that. And we just have to make these points work a little harder. It's always better to pull the points farther and make the points work harder than it is to add more points. Ideally, we want these guys to do as much lifting as they possibly can without adding additional complexity. Now, I've got a curve already, and that looks great. I'm going to just mirror this because I'm lazy. And it gives me most of the stuff I want already. I just need to change its frequency a little bit with scale. And that gives me pretty much what I'm looking for. So the efficiencies here, we want to, we want to work as smart as we can. And anytime that you have a situation where your points are matching from here to here, it's going to make it easier to surface stuff because we can just do things like this. We can just do things like this, okay? It's simple, really. Now, the cool thing about this is we've got a nice point structure so that when we want to start changing the shape on this a little bit, if we pull this out like this, the center of this thing actually has an inflection in it that allows this to bend around like that. Now, why wouldn't I model that in implicitly? Why would I go to the trouble of actually pulling the points? Because the surface is simple enough, I can make it do whatever I want. Because I understand the 1, 2, 3-ness of it, if I want to add an inflection here, I can just do this. If I want to tuck this in, I can just do that, which I actually want to do. And that gives me, the understanding and the control to be able to manipulate this surface to do what I want. So I can look at the shapes, I can look at the highlights, I can read what this thing's doing, I understand what's happening, and it all becomes much less mysterious, and you're much less a victim of, Rhino doing whatever it wants and you not having any say in the matter, right? We want to be able to have control over this stuff. That's the key. You want to be the driver, not the passenger of your models. All right, so to close this guy up, I'm going to use my favorite trick, which is just blend surf, and I'm going to override this and go 0.1, 0.1, and it makes a lovely little crowned surface with slightly rounded edges, which is what I want. So let's do the same thing down here. I had somebody joke once that my tutorials weren't so much modeling demos as they were blend surface demos. And I was like, well, I'm not even mad about that because you're not wrong. Because blend surface really is a brilliant tool for doing any of your modeling transitions. So we've got this main shape here, and that's pretty great. So if we look at this in rendered mode, you can see that we end up with, let's get a metal on this. You can see that we end up with a really nice kind of rounded edge there with almost no work, right? We love that. We love great results with little work, right? I think Bill Gates is credited with that whole idea of give a lazy man a job and they'll figure out the simplest way to do it. He's not wrong. So let's add this secondary shape in here. And the secondary shape, it's interesting. I was looking at this thing, and the secondary shape really, it's not precise. It's not precisely aligned. It's actually kind of weirdly aligned, and the shapes don't really match. And I'm going to split this by point here and here. And then I'm going to turn my points on. I'm going to change degree on this because it's a degree 2, and I'm going to make it a degree 3 so that now after mirroring is an edit on the original surface automatically transferred. Yes, if you do it with history. So if you mirror something, if I take this surface and I mirror it with history on, and I do something to it, that one will update. And the cool thing about this is if, I think that, yeah, that killed history. So let's do this. The cool thing about this is if you mirror this, and let's do it, I don't want to do it that far. Let's mirror it like that. So we've got history here, right? Because we did this. We had history recording down here. If I take blend and I blend from the original object to the mirrored object, yeah, you know, like this. Check this out. It all updates. So I can take that one step further and do this. And as long as I go into the original part and don't mess with anything else in the history chain, because this is the parent, right? So if everything has to come from the parent, check that out. It redoes the tangency. Fun stuff. Now, fun fact, blend surf, check this out. If I run blend surf again, there's an edit option in the command line. Select blend to adjust. The two that can be adjusted are highlighted. If I click this one, check out, I can go in and modify the properties of that. I can even change from tangency to curvature back and say, okay, run that again. I can do the bottom one now. Go back to the original parent. Readjust that, and it all adjusts again. So as long as you keep track of who the parent is, and ideally, I've been campaigning for years to have the parent have a different color, but, you know, who am I? What do I know about Rhino? Ran a consultancy for 20 years, making a living running Rhino 15 hours a day. What do I know? As long as you keep track of the parent, then you can set up these kind of more interesting history chains and do some cool stuff with it. Okay, so let's go back to this. And we changed degree on this, so we've got more points. So I'm just going to edit these guys here like this. And then I'm going to edit these guys. And then pull these guys a little bit. And it's funny because I was looking at this shape and I was like, wow, this is a really inelegant shape. It's really kind of doesn't relate to anything else. And it's like, as a designer, I look at it and I'm like, man, these curves need to get finessed. But it's entirely possible that in the world of hammer technology that there isn't actually a reason why this stuff is set up this way, like to keep the head from shattering when you smash it into something, or to change the resonance, or whatever. Who am I to question it? So we'll just go with something like this. I'm an art school nerd. I didn't go to engineering school, so I have to take a lot of what people tell me for granted. All right, so let's move this around something like that. And we've got our curve. I use the cell last command because that's the last thing I selected. And let's arrange this in a way that makes sense. And then I'm going to use one of my other favorite tricks, which is to grab the points on a curve. Turn the points on. And I'm going to grab the points, and I'm going to use the bend command, and I'm going to bend these that way. And then I'm going to bend these guys that way. And I get a nice procedural kind of thing there. And then I'm going to do the same thing this side. I'm just going to bend these guys back like that. And that is approximately what this thing is doing in real life. So, looks like this guy needs to get tucked a little bit. And so now we got to figure out how to make a surface out of this, because it's no longer planar, right? It's got all sorts of crazy stuff going on. So let's do something simple, and let's just split this in half. And we're going to split it by point. And then we will loft from one side to the other. Like that. Now, let's look at the points on this and make sure nothing crazy happened. And it looks like that actually did do some stuff that we don't love right at this edge right here. So let's do a rebuild on this. It's 4 and 9, so let's just use that, because we don't want to really like add complexity to it. But let's change it to 3 and 3. And then say okay. And that gives us a better shape. Now, you can see what's going on here though. This shape changed quite a bit. So we might not want that. And so in this case, we have to decide like what's going on with this edge. Is this something that we can live with? Now, I'm going to say yes, because chances are we're going to put a fillet on this, which means that this edge is actually going to get cut off, and we're going to have an edge that's interior in here that's actually going to do more of what we want it to do. So let's say okay with that. And now because I want to keep the point structure on this, organized in a way that I can keep track of. So I don't want to add a ton of complexity to this surface, but let's add some crown to this. And then let's pull these points out a little bit so that is shaping the way we want it to shape. And maybe we even rotate this just a hair like that. And everything still looks like it's kind of tucked where it needs to be. So let's mirror this. And then I'm going to just use the same trick I did before, which is to do a blend surf. And we're going to set this to tangency. And let that roll. Now, mess going on here. Don't love that. So let's cancel that and let's do something different. Let's loft from here to here. And then let's loft from here to here. That's a little cleaner version of what we had. So let's go ahead and join this up. And the one thing that I know that's going to happen is this edge is a little messy, but if I break that edge with a blend curve or with the surface blend, and it looks like that's not going to accept that because of that edge. So if I say select edges to blend, see how it's not giving me that? It's a closed edge, so what's going on? Why won't that behave? Who cares? I could spend time figuring it out, but I'm not getting paid for that. So let's do my next favorite trick, which is called a pipe trim. And let's just run a pipe around this thing. Use this to trim a gap. And in this case, we need to actually extend these just a hair. Delete that. Explode this because it's a poly surface, and then we'll just extend this edge a little bit. Like that. This guy doesn't want to extend because it's probably a trimmed surface, so let's untrim it. Now we should be able to extend it. If there's only one reason the surface won't extend, and that's because it's trimmed. So if you go to extend a surface and it doesn't extend, it's because it's a trimmed surface, so you have to untrim it. So now I have a gap. Now I'm just going to throw a blend surface on there. Because the last thing we're going to do is let Rhino tell us what we can or can't do. The second you let the robots get cocky with you, it's all over. Okay. So I'm going to call this good. And I'm just going to trim this in half. Because I already did one side. I'm not going to do both sides. So let's mirror this. Join. Bring it back. Take a look at what we've got. So we've got a couple of things going on here. This probably needs to get capped. This is already capped. I think I probably want to add my blends to this first. So let's do something like that and something like that. Probably want my blend on this. And then we can see how all of the rest of this stuff relates. Now, we might want a better blend here. If we do, right, because this corner is kind of, that corner is kind of sharp. So we can do one of two things. We can either redo the blend, or we can just come in here and split by isocurve and make a new gap. Hit T for toggle to change the direction. Now we've got a gap. Now we've got blend surface. Different shape. Let's do the same thing down here. Split. I'm using my hotkeys, sorry. You guys got to yell at me for that. Split by surface isocurve. This is the finest in eyeballing technology as far as like, how far is that? I don't know. Does it look good? To which all my engineers go, oh, idiot. Can't be bothered with things like measurement. I'm an artist. All right, so better relationship to that. So let's just smash this all together and figure out what we've got. So in this case, if I take these guys and I Boolean, it does the exact opposite of what we want it to do. Why is that? That is because one of these is flipped inside out. This is a closed object. That's a closed object. So we know the normals are pointing out by default. That's an open object. So logic would say, this is where the normals are backwards, and we can check it with the dir command, direction, and we just flip them. So now that they're pointing out, when we do a Boolean, it does what we expect it to do. So now, for the blending on this, we might be able to get away with a blend. Might be able to get away with a bigger one. And I'm all for it. Like, if you can get away with using the button clicky tools, go for it. That's great. If not, then we're going to go back to our pipe trim. and we're going to run a pipe around there. We're going to trim a gap, and then we're going to run a blend. And I think I'm just going to sneak up on this and see how big we can get before it starts wetting its pants. Because I want this to be fairly generous. But, okay, so looks like about 1 is about as far as we're going to get. That's fine. That's actually, I'll buy that. And for what it's worth, I'm actually using the right click on this, which is blend and not fillet. So this is a continuity-based thing, not a ball fillet. And I like how those look better. So we'll call that good. Let's see how that looks. I'm going to make this slightly less polished so we can see it a little better and make this a little darker. So that's coming together. I'm okay with that. I don't think the blacksmiths will chase me out of town for asking for that. So then the last thing we're going to do is we'll just Boolean this together. And again, it flipped inside out, which means this is the open one, so it's probably backwards, and it is. So we're just going to flip it. And then we just need to fillet this edge through here. Now this one might be a complicated one. Let's see what happens. Why did you flip it? Because, let's go backwards. Because this, with the normals pointing in, look what happens when I Boolean it. Bloop. It does the exact opposite of what I want. So if it doesn't do what you want, I want this and this to combine into a chunk. If it does the backwards thing, that means something's inside out. And you use the dir command to figure it out. In this case, the normals on this piece were pointing inside. So now we Boolean this. Okay, so last thing we're going to do, try and run a blend around this. Now, this may fail because it doesn't have enough space to do that. So let's sneak up on it, 0.5. And I tend to, if this stuff doesn't do what I want it to do really, really quickly, I tend to then say bail out of that. And then I pick this, I duplicate a curve out of this, I join that curve, and I make a pipe out of it. Because now I can determine exactly how big I want this to be. And if it self-intersects in the corner, so be it. Because what I'm going to do is I'm actually going to now come in here and fix this object wherever it's self-intersecting. So in this case, that corner is pretty close. That one's, not even close. Everything else is fine, but this is where the fillet's failing, and you can see why it's failing is because there's not enough room in here for this to do its thing. So all we're going to do is just explode this entire thing. We'll delete this corner. We're going to split by isosurface, or split by isocurve, and I'm going to make a gap that's bigger, and then I'm going to blend surf. Shh, don't tell them I'm using my hotkeys again. And we're going to make a blend that now is clean in that corner, and that problem goes away. So let's get rid of all this. We're going to split by isocurve. This is like the world's oldest modeling trick. This is something I learned back from, there was an old video series called Form versus Shape, and I religiously went through those tutorials, and this was the first time I saw this pipe trim trick, and I was just like, oh my god, that's brilliant. So I have stolen it as my own. By the way, the blend surf, pay attention to what's going on here. Pay attention to where the start and ends are. So if I start this here and here, there is also a direction. Make sure that the arrows are going in the right direction. They have to point in the same direction, otherwise that thing is going to fail. So that works now. This one is close. I'm just going to delete it and redo it. It could be better. Let's see how the start and ends are all crazy. We don't want that, so let's have the start be here, let's have the end be there, and then we change the direction. So now that corner is okay. And that one is self-intersecting a little bit also, so let's fix that. Again, pay attention to where the start and ends are. And the direction. So now that our cutting object works, should be a closed poly surface, and it is right there. Now we can take this and we can use this to trim this object, and we're going to model a gap. Sometimes we model surfaces, sometimes we model holes. In this case, we wanted to model a hole, and we wanted the hole to be modeled in a very specific way. Because now that it's modeled in a very specific way, we can fill it with blend surf, and it's going to work. Now all we have to do is just add a few shapes to kind of help it find its way along the way. I'll show you a model that I cut my teeth on when I was learning how to do this. It was one of my early, if you don't know, I was a contract modeler for Mattel for 17 years, and I worked almost exclusively on Hot Wheels. I built about 400 different Hot Wheels cars over the time that I was working with those guys. And one of the ones that I built was this one called a Flying Fortress, and it was an old B-17 bomber. And it was surface upon surface upon surface upon surface upon surface, blended, 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 blended. And I'll show you that model real quick if we've got time at the end of this. But this is where I kind of perfected this technique for myself. So now it's saying it's an open poly surface, so let's figure out where right there is the problem. So let's extract that, and let's just split the bad stuff out. Nobody has time for that negativity. Join that up, and we'll just do whatever. Doesn't matter. Whatever kind of surface we want to throw in there. Do a 2-rail sweep. It's fine. Now that's closed. So let's just mirror that. So we're going to split this in half. And nope, stop doing that. Mirror this. And that gives us that kind of shape. And now that I'm looking at this, the ball peen doesn't go in flat here. It actually blends into that. So let's do this. Model a gap. And then we'll blend. Chain there, chain there. Let's pick a center line spot to start from. And on this side, it's pretty tight, like that. And you can do that all day, right? You can just trim a hole, model a gap, trim a hole, model a gap, trim a hole, model a gap. Now, the top of this pokes all the way through. So let's just go, bring that up a little bit. And we can, I think I want that to be a little rounder. So let's, say it with me, kids, model a gap. I was teaching a live class once, and somebody turned this into a drinking game. Every time I said model a gap, they were like, mm. All right, and then that actually has a little shape kind of cut out of it, so I'm going to use this as a cutting object. Using this, and I'm not going to delete the cutters. And then this actually has a little blend on that thing, so I'm actually going to do a pipe trim on that, because I'm not even going to bother trying to figure out what's stupid as a curve first. I'm not even going to bother trying to turn that into a fillet. So that all completes okay. Doing this in wireframe is kind of the easiest way to do it. Chain this. Done. Really easy technique. You know, it actually works remarkably well. And there is a little, so this is actually pushed in a little bit, but it is kind of like that. One thing about the gumball cutter, it cuts through everything in the scene. So only use it for stuff that you're going to cut. And then the last piece of the puzzle is just right here. And I think we're going to get away with a little bit bigger one. It's not procrastination. I'm just waiting for panic to focus my efforts. All right. Hey, how did I select only a single object for the cutter? There's an isolate command, so I've got a couple of objects here. If I only want one of them, I pick it and type isolate. That object is now the only thing in the scene. And then if I type show, it brings everything back. So that actually worked out all right. Let's take a look at the, I'm feeling pretty redeemed from my last hammer disaster. So that gives us a little better version of that. If we wanted to get really crazy, we could make a different metal. And we could sub-object assign by shift-control clicking those faces. So now we've got two different finishes going on there. So this one, if we make this one a little darker, we can see that it's got its shapes in there. We've got our speckles on our handle. So let's hide our image. What time is it? 10:23. Let's hide our image. And let's Let's just see what an out-of-the-box ray trace looks like on this. Woo! That's spicy. Let's knock that down a little. Shows everybody how to override the default and then ends up going back to the default. Actually, let's change that to a different material. Here, this will be fun. Let's go back to plastic. Change that to speckle. And let's make this extra small. Yeah, I'm okay with that. Maybe looking at it this way is a little better. And then let's change I like to change the camera from 50 to 35. I just like it gives it a little bit more perspective and a little bit more drama. And for an out-of-the-box, drag and drop, default environment, no effort rendering, I'm going to call that pretty good. All right, any questions? Anything you saw that was like, whoa, what was that? We need to talk about that more. Awesome. Okay. I think I'll let you go. I think we landed this much better than I was kind of hoping. So, did you only use the standard toolbar? Yes. The only thing that's custom on this is my pop-up. And I will dock that, so if you want to take a screenshot and see what's exactly in there. These icons, this is the standard trim and the standard split. If you hold down Shift and right-click, it brings up the button editor. And if you click this, you can go in and actually, model the stuff. Oh, can we see Hot Wheels model? Yes, absolutely. So that's finished. Let's call that done. And then I'm going to just export this image so I don't have to do it later. Capture viewport to file, this one. It's funny because first of all, thank you, I appreciate that. Second of all, there are some techniques in here that took me a really, really long time to figure out on my own, and no one showed them to me. I'm almost completely self-taught with Rhino, and I learned everything I learned by forums and bugging Pascal and JB and all the guys that used to work here before I did, and so having a video like this is kind of my gift back for everything that Rhino has given me over the years, because I didn't have this stuff. And so I hope that I can save you a lot of years of fumbling to have this kind of stuff. So all right, so let's take a look at. This is spinning. Why are you spinning?